What do cars, precision-guided missiles, and the television you're watching right now have in common? They all depend on something called rare earth elements.
Right now, huge pumps are running in West Virginia, pulling thousands of gallons of toxic water out of the ground. To the naked eye, it looks like a cleanup crew working on an environmental mess. But that's not the full story. These crews aren't just cleaning the water, they are mining it. They are filtering out a secret ingredient that could change the entire global economy.
When the idea for collecting rare earths from that stream came along, I thought this is a nice way to add a revenue stream and help pay for that process.
While the rest of the world fights over deep underground mines, American engineers are finding critical defense metals floating right on the surface. It changes everything we thought we knew about mining, and the clock is ticking to get it out. The orange water deception. Basically, this mess comes from abandoned coal mines hidden up in the hills. When mining companies dug tunnels years ago and then walked away, they left behind walls of broken stone filled with a mineral called pyrite. You might know it as fool's gold. By itself, it's useless. But when air and rainwater hit that pyrite, a crazy chemical reaction starts. The mineral turns into acid. This acid eats through the surrounding rock like a hot knife through butter, dragging heavy metals out with it. This creates acid mine drainage, a toxic soup that pours out of the mountains and into the streams.
This is the opening to an abandoned coal mine, the Essex mine, with toxic metal sludge. This is where the Sycamore Run comes through and carries pollutants into Monday Creek.
For decades, the government spent millions of dollars trying to stop this. They treated it like a curse. It ruined drinking water and destroyed property values. But then some geologists from West Virginia University decided to test that sludge one more time. They weren't looking for iron or aluminum, which everyone knew was there. They were looking for something much rarer, and what they found made their jaws drop. The acid wasn't just pulling out junk metals, it was pulling out rare earth elements. These aren't just random rocks. We are talking about the 17 specific metals that power the modern world. They are in the speakers of your phone, the motor of your electric car, and the guidance system of a cruise missile. The study found that the drainage in this basin releases millions of pounds of these rare earth elements every single year. The pollution that everyone hated is actually a flowing river of strategic resources. The numbers are staggering. Researchers estimated that the amount of rare earth metals floating in these dirty creeks could equal nearly half of what the entire United States uses in a year. Think about that. For years, the U.S. has been panicking about running out of these metals, buying them from foreign rivals, while millions of pounds of the stuff were literally flowing past their feet.
Just doesn't make sense to a conservative to say, these minerals that are in the deep sea bed are so important to the United States, we are done without those. Let's put an international bureaucracy in charge of getting us access to them.
The reason this happens is simple chemistry. Rare earth metals love acid. In a normal, clean river, these metals stay locked tight inside rocks. You can't get them out. But in the acidic brew of a mine site, they break free and float downstream. It's like the mountain is doing the hard work of mining for us. The natural acid dissolves the ore, and the river acts like a conveyor belt, delivering the metals right to the treatment plants. Decker's Creek is the perfect example. Just upstream from Morgantown, there's a spot called the Richard Mine. It leaks a steady stream of low pH water that looks terrible. But when scientists tested the sludge, the mud that settles at the bottom of the treatment ponds, they found gold. Well, not literal gold, but something better. The sludge contained rare earth levels that matched some of the best mines in the world. So instead of digging massive open pits and destroying the landscape to find these metals, engineers realized they could just catch them at the water treatment plant. The U.S. government and local groups built a massive facility at the Richard Mine site. It was designed to clean the water, but now it serves a double purpose. It's catching the strategic metals that the military and tech companies are desperate for.
New technology has triggered a fierce competition to go get them. These metals are critical for modern life. 19 countries, including China and Russia, have already jumped into the deep. But the one country on the sidelines? The United States.
It sounds too good to be true, but the data backs it up. The sludge in these ponds holds about 1.5 pounds of rare earths for every ton of dry mud. That might sound small, but in the mining world, that is a high-grade deposit. And the best part? The hard part is already done. In traditional mining, you have to crush tons of rock and use nasty chemicals to get the metal out. Here, the rain and the pyrite did that part for free. The metal is already dissolved, waiting to be scooped up. This discovery flips the script on the entire industry. The U.S. has been dependent on foreign supply chains for decades, specifically from China. But now it turns out that the rusty, forgotten creeks of Appalachia might actually be the key to energy independence. The orange stain on the rocks isn't just pollution anymore, it's a national treasure map. The orange mud is valuable, but getting the metal out isn't as easy as using a sieve. The sludge refinery. It is one thing to find metals in a river, but it is a whole different game to get them out in a form that you can actually sell. You can't just scoop up the mud and stick it in an iPhone. That mud is a mess of iron, aluminum, and a dozen other things nobody wants. To fix this, engineers had to get creative. They developed a brand new way to treat the water that separates the trash from the treasure. It happens in big mixing tanks. Usually, workers just dump a white powder called lime into the water to eliminate the acid. This makes all the metals drop to the bottom at once, creating a giant mess of mixed up sludge. But the team at West Virginia University realized that was a mistake. They figured out that if you change the acidity in steps, you can sort the metals out. Here is how it works. First, they raise the pH of the water just a little bit to around 4.5. At this level, the iron and aluminum, the junk metals, get heavy and sink to the bottom. They clear that stuff out. Then they take the remaining water, which still holds the rare earths, and raise the pH again, this time to 8.5. That is the magic number. The rare earth metals suddenly drop out of the water and settle as a thick, valuable sludge. By doing this two-step dance, they create a concentrate that is way more valuable than the normal waste. At the Richard Mine plant, they even built separate pipes for this. The regular sludge goes one way and the money sludge goes another. They pump this special mix into huge white bags called geotextile tubes.
It's the richest source of scandium we've come across so far. And DEP is treating this water, and they're separating out the sludge by running the effluent from their treatment plant into these things called geotubes, which are these big, long sacks that naturally dewater.
They look like giant pillows sitting on the ground. The water drains out through the fabric, leaving behind a dense, heavy paste that is loaded with critical minerals. Once that paste is dry, it gets shipped to a pilot facility in Morgantown. This place doesn't look like a science lab, it looks like a factory. It's full of tanks, pumps, and steel frames. This is where the real magic happens. They take that dried orange mud and dissolve it in acid again. It sounds counterintuitive, right? They just took it out of acid and now they are putting it back in. But this time it's controlled. They use a process called solvent extraction. Think of it like salad dressing. You know how oil and vinegar don't mix? Well, these guys use a special oil-like liquid that is designed to only grab onto rare earth metals. They mix the dirty water with this special oil. The rare earths jump into the oil, leaving the impurities behind in the water. Then they let the liquid separate. They do this over and over again, purifying the mix at every step. By the end of the line, they wash the oil with clean acid and strip the rare earths back out. What they are left with is a pure powder, rare earth oxide. This is the stuff that sells for big money. We are talking about purity levels of 98% or higher. That is high enough to sell directly to the people who make magnets and batteries. And get this, the sludge isn't just full of the cheap stuff, it contains the heavies.
Treating acid mine drainage leaves behind tons of sludge that contains mostly iron, aluminum, and manganese hydroxides. The sludge is typically sun-dried in large ponds or in dewatering containers such as 10K geotubes shown here.
In the rare earth world, elements like dysprosium and terbium are the heavy hitters. They are incredibly expensive and hard to find. The sludge in West Virginia is surprisingly rich in these heavy elements. At one site near Morgantown, researchers estimated the rare earths in the sludge could be worth $1 million. And that is just one site. There are hundreds of these sites all over the region. Basically, the U.S. has built a factory that runs on pollution. The inputs are toxic water and lime. The output is clean water and strategic metals. It is the ultimate win-win. But making this work in a lab is one thing. Doing it while the world's superpower is breathing down your neck is another. Because the country that currently owns this market is watching all of this very closely, and they are not happy about losing their grip. The U.S. found a way out of the trap, but Beijing just slammed the door shut. The embargo crisis. For the last 20 years, the United States made a massive gamble. They decided it was cheaper to buy rare earth metals from overseas than to mine them at home. It seemed smart at the time. Mining is dirty and expensive. So America closed its mines and let China take over. And that's putting it lightly. Today, China controls nearly 90% of the processing for these metals. They own the game. This wasn't a problem until it was. Washington realized way too late that you can't build a modern army or a green economy if your rival controls the off switch. And in 2025, that switch got flipped. Tensions were already high between the U.S. and China over trade and technology. Then, on April 4, 2025, Beijing dropped the hammer. They announced strict export controls on 7 key types of rare earth metals. These weren't just random choices. They picked the exact metals used in high-performance magnets, the ones needed for electric vehicle motors and military radars.
Hybrids in particular use a lot more because they contain electric motors that would not function without rare earths.
Suddenly, companies couldn't just buy what they needed. They had to apply for special licenses, and the Chinese government could just say no or let the paperwork sit on a desk forever. The impact was immediate. Exports of some magnets dropped by 75% in just a few months. Factories in Europe and the US started panicking. Imagine running a car factory where you have the chassis, the tires, and the glass, but you can't finish the engine because you are missing a few ounces of a specific metal. That is the reality manufacturers faced. But it didn't stop there. In October 2025, China tightened the screws even more. They didn't just ban the metals, they banned the knowledge. New rules made it illegal to export technology related to mining and processing rare earths. They basically said, not only will we not sell you the metal, but we also won't let you learn how to get it yourselves.
Rare earths normally are found in very, very low concentrations. This is probably running something in the 25% grade, which is remarkable. To anyone who has ever worked with rare earths, this is a thing of beauty.
It was a clear message. China considers this a national security issue, and they are playing for keeps. This is why the river discovery in the U.S. is such a big deal. It's not just about cleaning up a few creeks in West Virginia, it's about survival. The U.S. military uses rare earth magnets in everything from nuclear submarines to the F-35 fighter jet. You literally cannot fly that plane without these metals. Being 100% reliant on a country that just restricted exports is a nightmare scenario for the Pentagon. The pilot plants in Appalachia are proving that the U.S. doesn't have to be held hostage. The material is right here. It's sitting in the waste piles and the rivers. The Chinese dominance is built on the fact that their mining is cheaper and they have the refineries. But the acid mine drainage method cuts out half the cost of mining because the rock is already dissolved. It gives the U.S. a fighting chance to break the monopoly. Critics used to say that extracting these metals from water was too expensive to be worth it. But when the alternative is having your supply chain cut off completely, the price doesn't matter as much. The geopolitical game has changed. This isn't just business anymore, it's an arms race. And the battlefield is a muddy treatment pond in the middle of nowhere. West Virginia was just the start. The hidden empire is bigger than anyone thought. The National Blueprint. Here is the crazy part. This isn't just a West Virginia story. Once scientists realized that acid mine drainage creates a natural rare earth concentrate, they started looking at other dirty water all over the country. And they found it everywhere. Take the Berkeley Pit in Montana. It is one of the most famous toxic sites in America, a massive open-pit copper mine filled with billions of gallons of acidic water. It's so toxic that if a flock of geese lands on it, they don't take off again. People have been trying to figure out how to clean it up for decades. But now, researchers are looking at that deadly lake and seeing a fortune. The same technology developed in Appalachia can work there. The chemistry is the same. The potential volume of metals in the Berkeley Pit is astronomical. This is turning into a national blueprint. We are seeing a shift where environmental cleanup and national defense are becoming the same thing. The Department of Energy is pouring money into this because they see a future where the U.S. doesn't need to open massive new mines that destroy the wilderness. They can just hook up pipes to the messes we already made. It is almost poetic. The pollution from the Industrial Revolution, the coal and copper mining that built America in the 20th century, is now providing the materials to build the 21st century. The waste of the past is the fuel of the future. We are talking about a network of these treatment plants running across multiple states, feeding a domestic supply chain that China can't touch. So, do you think this river mining is the silver bullet the U.S. needs, or are we just scratching the surface of a much bigger mystery underground? Is it really safe to be messing with these chemical flows? Let me know what you think in the comments below. If you learned something new, hit that like button and subscribe for more deep dives into the stories they don't tell you on the news. See you in the next one.